Hello everyone. So as we know that NMR spectroscopy is a use of nuclear magnetic resonance phenomena to study the physical, chemical and biological properties of matter. Chemists use it to determine molecular identity and structure. So using this NMR spectroscopy, we can draw proton spectra, carbon spectra, nitrogen spectra and so on, but today we will mainly focus on carbon spectra, and I will show you a difference of certain three different methods. What's the advantage and disadvantage of the three types of methods. So 13C CPD composite programmed decoupling, 13C Attached-Proton-Test Spectra, 13C DEPT is distortionless enhancement by polarization transfer. To show it more clearly, I will show you one example. I will show you one example of a structure. So from here we can see that we have totally 12 carbon atoms, naming visible below, and using this software we can predict NMR spectra of 13C NMR spectra. So from here we can see that we have 8 quaternary carbon atoms and 9 quaternary carbon atoms and 3 primary carbon atoms which attach to proton, and another all of them without proton. So for using this one we are going to structure, predict, and it will give us predict to our structure. Carbon spectra. So before measuring with the instruments, it's a bit always to use this software. It's giving us some idea regarding the structure. Here is visible 8 peaks, but I've already mentioned that there are 12 carbon atoms, but we should consider that these carbon atoms relaxation will be same. That's why 1 peak will be for them, and for 2 carbons of carbon groups relaxation will be same. That's why it will be appear only 1 peak. It's a difference. That's why relaxation will be different. It will be appear different peaks. So, and just simply I will try to explain that why we need to use C13 CPD, C13 DEPT, C13 APT. So if we will go to C13 CPD, we can see that 8 carbon peaks and 1 is our deteriorated dimethyl sulfoxide solvent peak. So total 8 peaks here. It's 30, so I will not consider this one. So total is 8 peaks. So it means so then if I will go to depth 135, there will be only 2 peaks, 2 carbon peaks and 1 solvent. If I will go to depth 90, there also again will be 2 peaks, but here will be it's a solvent peaks. And if I will go to APT, there also will be 8 peaks and 1 solvent peaks. So if you will compare 13C CPD and 13C APT, just a difference only will be 2 peaks is downside, but almost 8 peaks is visible here and here also. But if you will go to depth 90 and 135, there will be only 2 peaks. So, what it's showing us, if during the measurement with depth 135, we can identify CH, CH3 and CH2 groups. From our structure we can see that we don't have CH2 and CH3. We have only quaternary carbon atoms and primary carbon atoms. So if there will be in CH2 groups, it will be downside. If the CH and CH3 groups will be upside, but no quaternary carbon atoms. So it's a main disadvantage of the depth 135. Using this depth 135 or just depth method depth 90, we will never identify quaternary carbon atoms. It's null and it's not visible in this method. So but depth 135 and depth 90 looks the same. So, but in depth 90 we can identify only CH carbon atoms because there will be appear only primary carbon atoms which are attached to one proton. It's a 2 and it's a 2. So it means in our structure we don't have CH3 groups carbon atoms. It's already approved that really we don't have CH3 carbon atoms. Then if we go to 13C APT, we will see that 8 carbon atoms but 2 downside. So with 13C APT we can identify quaternary carbon atoms, tertiary carbon atoms, primary and secondary. And primary and tertiary carbon atoms will be downside, quaternary and secondary carbon atoms will be upside. So just it's a difference, C13 APT and C13 CPD. So and also using 13C APT you can save your time, because compared to certain CPD it's giving quick result. But you should consider one thing always, that in 13C APT methods quaternary carbon atoms peaks will be smaller compared to 13C CPD. So conclusion, I think I have already tried to explain more clearly to yourself. So if you are trying to identify your compound, your structure, it's better to use combination of the structure, because if you will use only 13C CPD you can identify all carbon atoms, and later actually you can go to approximate certain NMR chemical shift of some common groups, and you can identify which carbons belong to groups. You can do like this. But if you have questions that how many quaternary carbon atoms do you have, how many primary, secondary and tertiary carbon atom you have, so it's better to use this combination of these methods, not alone. So first is 13C CPD, since you are going to use 13C APT, it's giving you an idea how many carbon atoms do you have, because downside it will show you CH and CH3, and upper side it will show CH2 and C carbon atoms peaks. Then you are going to DEPT 135. In here again quaternary carbon atoms will be null, because in certain APT you can see quaternary carbon atoms, but in the DEPT 135 you cannot see quaternary carbon atoms. So you can compare the peaks of 13C APT, 13C DEPT 135, and you can understand that which peaks belongs to quaternary carbon atoms. And here you can see only CH and CH3 upside and CH2 downside. So here CH downside, no any peaks visible. According to our structure we don't have CH2, so it can be CH and CH3. So if you want to more clear information, you are going to later to 13C DEPT 90. Here again 2 peaks, so it means we don't have CH3 groups in our structure. So because in DEPT 90 I have already mentioned before, there will be visible only CH carbon atoms peaks, so primary carbon atoms peaks which are attached to one proton. So using this type of methods with combination you can identify your structure easily, and it gives you some clear idea, and it can be beneficial for you in future.